Okay, hello everyone. So today's session, I hope you all had a great day so far. It was a somehow beautiful day with all the rains and thunderstorms. Let's start our session with continuing talk about the procedure solving problems and questions regarding the random variables. You're still on solving the problem with the single random variables, and we are going through the homework number 4 that we had. So far, we already gone through the 3 first problems. Now we are gonna talk about the 4th problem. But before I start, I wanted to see if there is any question regarding what we discussed in previous session for the first 3 problems. Any question? No? So good. Let's move on to the 4th. Do you have a question? Yeah. I definitely talk with them again. I don't know what the problem is because they already published the grade once. Do any one of you could see the grade for the homework 3 or quiz 7? No? I'll just okay, I will look into that. Okay. Thank you. I will definitely look into that. Yeah, thank you. Okay, any other question? No? So let's start with the problem number 4. In problem number 4 in homework 4, we have a question that tells us that we have an NBA basketball player, okay, shooting an uncontested 2-point shot, and that player will make the basket with probability of 0.6, okay? However, if the opponent foul the shooter, the shot will be missed, but 2 free throws will be awarded to the other team. Each free throws is an independent Bernoulli trial. Remember Bernoulli trial? I think we know what Bernoulli is. It's when we have an event that have only 2 possible outcomes, like a flip of a coin, or like this example, success or failure in shooting a ball for a basketball player, okay? So we have a Bernoulli probability with the probability of success equal to P. Now, based on the expected number of the points that shooter will score, for what value of P it's reasonable to foul the shooter. Is that clear, the question? So we have a basketball player. We could shoot for like a unprecedented 2-pointer, okay, with a probability of success equal to 0.6, or we could foul, which means the player would lost that 2-pointer, but is going to be awarded 2 shots, each 1 point, okay? But the probability of the player making those shots, each shot, the probability of success is P, and the 2 shots are independent. Now we want to see if it's reasonable for what probability of P is reasonable to fool. That means we have to find the probability P that the success rate is going to be lower than the success rate of a free 2-pointer. That shot of 2-pointer. Is that clear? Now, how we could do that? First of all, we have to calculate what is the probability or expected outcome that we have on that on that free pointer. We have the value of X, which is the number of points that a player could get, is our random variable. For that unprecedented shot, the only possible value for X is 2. And the probability mass function for that random variable is 0.6. Okay, so let me correct that. So in X, when that unprecedented shot, either the player could get the shot into the ball, do the ball to the basket, which means X equal to 2, or cannot get that. So we have two possible outcomes, which means X equal to 0. So the PMF of that value is 2 for X equal to 2 is 0.6, and if not, is going to be 0.4. So this is the PMF of our 2% that free shot that we have. Okay. So are we clear so far? How we develop that PMF out of the information in the question? Now, what is the expected outcome? Okay, which means the expected probability, the expected value out of this random variable X. So when the player shoots that 2-pointer, okay, how you calculate the expected outcome? It's summation of X, PMF of X. Are we good? So it's gonna be the summation of X, P of X, which is 0 times 0.4 for one value, plus 2 times 0.6 for the other value, which basically this is 0. So it means it's 1.2 is the expected value of first PMF. Correct? Now, let's see what the other event means. The other events, we have the fall, we did fall the player. Now the player has 2 shots. Okay, so it's a sequential kind of like probability. Is that clear for everyone? So it has 2 shots. In order to calculate the expected value, okay, either we have, like you could calculate the expected value of the new PMF, okay, the new PMF, which means X equal to 0, X equal to 1, and X equal to 2. Okay. And now you have to like calculate the expected value for each of these PMFs. X equal to 0 means two loss of the point, which is 1 minus P, okay, multiplied by each other. So it's 1 minus P square. We have 2 shots unsuccessful. Okay, the X equal to 1 is 2 possible outcome. First one fail, second one success, or first one success, second one fail, which is P times 1 minus P in each trial, in each category. So we have 2 times of that for X1. Is that clear what I'm talking about? So the PMF for X0 is 1 minus P square, because we failed twice for the 2 shots that awarded. For the X1, 1 is failed, 1 is success. So we have 1 minus P times P, but we have 2 possible way of making such a random variable. So we have 2. Okay. And for the X equal to 2 means both of those shots are successful, which is P squared. Same way, you calculate the expected value of P. If you do that, you would come up that the expected value of this new PMF is going to be 2P. Regardless of that, we know Bernoulli function. We could use the formula that I already gave you for the expected value of a Bernoulli PMF. Are we good? So we have 2P. Now, in order for us to be reasonable, to make a fault, to fool the player, have a fall on the player, the 2p should be lower than the expected value for the original 2-pointer. Otherwise, it's not reasonable to conduct a fall on the player. Is that clear? That's kind of like the logic of that. So that means that 2p if 2p is less than that 1.2, we should fool the player. But so this means we have to fool. And if 2p is bigger than 1.2, that means we shouldn't fool. That's the logic to how to decide to what to do with the player. Now, basically, you could calculate, it's a very simple kind of like analysis. You could calculate very simply the value of p. Okay, so generally, based on this function that we find, if p exceeds 0.6, okay, we should not fool the shooter, because then the probability of shooter, the player, making 2 points is higher than when we let him to shoot the 2-pointer, that unprecedented 2-pointer. Is that clear? The logic behind the solution? Are we good on that? So this way we could analyze for what amount of p it's reasonable to conduct a fall or not to conduct a fall. And the margin is 0.6, which basically is very low. If you really follow the NBA, it's very low unless it's Shaquille O'Neal. Then you could fool. He's going to lose that. Is that clear? Are we good? Now, question 5. The question 5 says, it can take up 4 days after you call a service to get your computer repaired, okay? The computer company charges for repairs according to how long you have waited, okay? The number of the days are represented by the random variable d, okay? And the charge is the random variable c. Now, we have the probability distribution for how many days it would take them to repair the computer. Okay, you have the PMF for D. Okay, and basically, and based on the number of the days, like D equal to 1, D equal to 2, 3, or 4, you have the function that defines C based on D. Remember, this is not the PMF of C. This is the function that relates D to C. Although in this example, it's very simple to calculate the PMF of C because it's like a bijection. It's map of 1 by 1. So it's basically the same PMF. You have to just map each cost to each D, and you have the probability based on the PMF of D. Okay? Now, what the question asks us? The question asked us that what is the expected value of waiting, meaning the expected value of the variable D. Again, quite straightforward, very simple question. You have the PMF, you have the random variable. The formula for expected value is D P of D for all the D's. Are we good? So basically, it would be 1 times 0.2 plus 2 times 0.4 plus 3 times 0.3 plus 4 times 0.1 and the result is going to be the expected value. If you do the summation, you would find the expected value of the company to do the repair, which is 2.3 as the expected value of the waiting time. Is that clear? Now, the second part asks us, what is the expected deviation, meaning the expected value of D minus mu D? What is the mu D? It's already noted in the first part. Mu D is the expected value of D. Okay, now, what is the expected deviation of a random variable? Expected value of D minus mu D should be 0. You don't even have to think about it. Expected value, expected deviation of any random variable, meaning expected deviation. Do not miss that with a standard deviation or any kind of like other thing. Expected deviation, meaning random variable, expected value of random variable minus the mean value. Okay? Always is 0. So you don't even have to think about it. Okay, so it's always a 0, but I already put the numbers. You could put the derivation, the ED of ED minus mu D. You could use that linear transformation for expected value that we learned the property of expected value. This is a constant number. So if you have expected value of D minus a constant number, it's going to be expected value of D minus that constant number. Okay, so you could divide these two terms. Okay, this is a constant number. Expected value of D is mu D, so it's going to be mu D minus mu D, which is 0. This is the mathematical derivation of what we talk about, that you should always remember the expected deviation is always 0. Are we good? Any questions so far? No? Perfect. Now, express C as a function of D. Basically, the question already gave you the answer when I map each day and each price. Okay, you just have to like rewrite that using mathematical notation. When the question told you that, okay, for 1 day service, we charge 90, it's dollar, right? Yeah, dollar. Okay, 1 day service means D equal to 1. Okay, so basically the function become, for D equal to 1, C is 90. And respectively for the other types, for the other variable values of C, you could define the values of D and come up with the mathematical notation of the function that relates C and D together. Is that clear? That was very simple, so I don't want to like spend a lot of time on it. The part D asks us for the expected value of C. Now, for the expected value of C, this question is very simple, but you have to come up because the expected value of C is summation of C, P of C. Okay, so the expected value of C is the summation of C, P of C. Okay, so you have to have the PMF of C. But this question, because it's a map of 1 by 1, the function between C and D is 1 by 1 mapping. Okay, basically it means the same PMF would repeat itself for C. The same PMF of D would repeat itself for C. So the probability of D equal to 1 would be the probability of C equal to 90. Okay, so it's easy to come up with the P of C, and it's gonna be, if C is 90, if C is 70, if C is 40, if C is 4, okay, you have 240. Okay, so that's a good point actually. Now, what is the probability of having C equal to 90? Is gonna be the probabilities of D equal to 1, correct? So what is the probability of equal to 1? 0.2. Okay, so this is 0.2 probability. For C70, D should be 2, correct? What is the probability of that? 0.4. Now you have two ways to calculate the probability of C. One way is to calculate, okay, what is the probability of C become equal to 40, which means either D is 3 or 4, which means the summation of the probabilities. So this one is 0.3 plus 0.1, which is 0.4. This is one way. Another way is that the summation of these three values should be add up to 1. So you have the 2, you could calculate the third. Okay, so two ways to calculate the third probability. Now that you have the PMF of C, now you could calculate the expected value of C. Is that clear? And it's going to be C, P of C. Is that okay? Any question? No? And this is like $62 for this problem. If you don't have any question about what we've done for the problem number 5, we could move on to the problem number 6. Good? Okay. And as I mentioned, in the final exam, I'm going to give you the PMF or PDF or CDF, so one of the functions. So you don't have to develop the functions in the final exam, but you have to know what to do with those information. Like if you have a CDF, how you could find the PDF or PMF, okay? Or if you have those, like PMF or PDF, how you calculate the expected value or the variance or standard deviation. You have to know those formula. And please pay attention. I'm emphasizing a lot on that. Bring those popular PMFs that I introduced you in the course and the formula for expected value and their variance as your note into exam. It saves you a lot of time because you don't want to solve the complicated integral in 2 hours exam. Okay, problem number 6. In the problem number 2, we had the cellular service, phone service, that if you remember, it would charge us $20 for the first 30 minutes, and it would add for each extra minute that you use the phone, it would add 50 cents to the bill. We already calculated the PMF, and we already developed the PMF for the cost based on the PMF that the question gave us for the minutes. Remember that? We solved that in problem 2 of this homework. Now the problem 6 asks us, okay, based on that PMF that we developed, what is the expected value for the cost or random variable C? Again, very simple, but you have to pay attention to the detail. The expected value is C, PMF of C, the summation for all the values of C. So you have the PMF of C. We already developed that in question 2. Now we calculate the expected value of C. Now, one process, what I say is different than what you see in the screen. What's the difference? What I introduced you is that, okay, you already developed the PMF of C in your in your problem 2. You could use C PMF of C and move forward. Now, what is another way that we show it on the screen is that if you remember, we said if we have a function of a random variable and we wanted to calculate the expected value of that function, we also could do, if you remember, we said if we have y equal to g of x, okay, the expected value of g of x become the g of x PMF of X, right? So another way to calculate the expected value of C is to use the function that defines C based on M. This is become this function here, and use the PMF of M directly and calculate the expected value for C. This is the second kind of like approach that we could take, which I put it in the solution for this problem. Is that clear? The two different approach to calculate the expected value of C. One is straightforward using the PMF of C. Another one is to define C as a function of M and use PMF of M and calculate the expected value for that function, which basically is the C itself. Are we good? And if you do that, this question is like an infinite series. So you might have like, I do not give you that such a question in the exam because I don't expect you to like know the mathematical trick. But for your kind of like information, I put the trick that we used for calculating this. If you use the summation, you would end up in such a value. Okay, you have a bias, the 20. You know where that come from? It's the default of the bill plus the summation comes from that summation that comes from the CPMF of C. Okay, now when you look at this summation, you see it's J times 1 minus P to the power of J minus 1. This P, this summation is over J. So this P is a constant number from the perspective of the summation. So you could drag the P out of the summation. Nothing would change. So what you have actually is X times a constant number to the power of X minus 1. And you have a summation over X from like 0 or 1 to infinity. Okay? Now, the summation of a constant number, this is a mathematical kind of like concept. Sigma of a to the power of x over the x from 0 to infinity will converge for a's lower than 1, which we know this constant number is lower than 1. Okay? Is going to converge to 1 over 1 minus a. Now, we don't want this. Our function is x a to the power of x minus 1. But if you remember, if you look at this, x to the power of a to the power of x minus 1 is actually the first derivative of a to the power of x in respect to a, not with respect to x. Is that clear? Ax to the power times a to the power of x minus x is d of a to the power of x dA. Okay? So if the summation is going to be equal to 1 minus a, the summation of this one is going to be equal to the derivation of this in regard to a. Mathematical trick. So it's become basically the summation of, I wrote it here, I hope it's visible, the summation of x to the power, x times a to the power of x minus 1 is going to be 1 over 1 minus a squared, the derivative of this value in regard to a. Now, what is a in our specific question is 1 minus p, correct? What is x is j. So this is this summation, we drag the p out of that summation, and we had j 1 minus p to the power of j minus 1. And using this rule, we would have p times 1 over 1 minus, a is 1 minus p squared. Okay? So it become P over P squared, which means 1 over P. Okay? Are we good? So the 20 is 20. 1 minus P over 30 is the constant number in our function. It repeats itself. We have the denominator, the 2 in the denominator, and this P comes from this summation. Is that clear how we reach this conclusion? Any question about that? No, it's kind of like that. I put that. I do not give you such a question in an exam. I don't expect you to know these tricks, but I want you to like get used to these kind of like mindset, you know, how to deal with this kind of question. Okay, we have AX. Now, if you take a derivative, you have X to the times AX minus 1. Now, how we could use those in order to solve our situation. You know, some sort of like a problem solving using other concepts. Is that okay for everyone? Everyone good? Perfect. Now, if you don't have any question, we could move on to the problem number 7. And basically, the expected value of the C become 20 plus 1 minus P to the power of 30 over 2P. So this is the solution. You have the solution in the canvas, so you could look into that. I draw on it. It's not quite clear here. Okay. Problem number 7, it says, in an experiment to monitor 2 packets, the PMF of N, defining N as the number of video packets, is what we see on the table. So we had a random variable N, and we had the PMF of N for the possible values that N could get, 0, 1, 2. That means otherwise the probability is 0. Okay? Now, find the expected value of N, the second moment of N, variance of N, and standard deviation of N. Now, again, very straightforward. You already have the formula. The question already gave you the values for random variable and the PMF. You just need to follow the formula. You have the PMF and the random variable. Expected value is N PMF of N. So it's going to be 0 times 0.2 plus 1 times 0.7 plus 2 times 0.1 and 0 for others. So if you do that and do the summation, you would find the expected value for N. Very straightforward, very easy. Just follow the formula. Is that clear? Now, for the second moment, you have to calculate the expected value for N squared. N squared, again, following the formula that we learned for G of X, Px, okay, you wanted to like calculate the expected value of G of X. Okay, here G of X or like G of N is N squared. So here is N squared P of N. Okay, so expected value of N squared, or as we call it, second moment of N, is going to be the probability times the square of each random variable. 0 squared times the probability, 1 squared times its probability, plus 2 squared times its probability. You do the summation, you find the second moment. Very easy, very straightforward. Now, you have the second moment, and you have the first moment or expected value. We already learned that the variance of any random variable is the second moment minus first moment squared. Remember this formula in the slideshow? So Very easy to calculate. If you don't want to use this calculation, again, you already know that the variance is the expected value of n minus mu n square. So this is the g of x here. Put it in the value in the formula. So it's going to be n minus mu n square times p of n, and do the summation. Are we good? Two ways to calculate the variance. And you could easily calculate what is the variance of the random variable x. Is that clear? The two approaches that we could have to calculate the variance. Now, when we have the variance, what is the standard deviation? 0. The standard deviation. Yeah, that was expected deviation. Okay? The standard deviation is very straightforward, is the square root of the variance. So you have the variance, take a square root, and you have the standard deviation. Are we good? Any question about what we done here? No? So, perfect. Now, question 8 is a little bit not trickier, but you have to like know what you're doing, or like have a deeper kind of like understanding of the values that it represent. Now, in question 8, we said that we have a random variable x with a binomial PMF, and we have the PMF. Okay, so we have the random variable x and the PMF of x. Now, the question asks you to find the standard deviation of x. What was the standard deviation of x? It was the square root of the variance. So in order to calculate the standard deviation, you have to calculate the variance. How you could calculate the variance? Either you could go directly for expected value of x minus mu x square, or you could calculate the expected value of x and the second moment and use this formula. Is that clear? Let's use the formula. That's a better kind of like practice. We calculate the expected value of x. It's xpx. We have the PMF, and we have all the x's that we could get. It's binomial chosen from 4. So it's going to be from 0 to 4. Okay. Is that clear? How upper limit is 4? Is that clear for everyone? Why the upper limit for that summation is 4? Because it's a binomial and the n is 4, so the upper limit should be 4. You can choose 5 out of 4. Okay, so we have each random variable time the PMF already given to us. So we do the summation and we find the expected value. We do the same for the second moment. X squared times P of x is not quite complicated. It's the same process, just x squared. And we have the second moment. Now the variance is second moment minus first moment squared. So 5 minus 2 squared, which means 5 minus 4, which is 1. Standard deviation is what the question asks us for. Is going to be a square root of the variance, which is the square root of 1, which is 1. Are we good? Now, I didn't need to actually give you the first part, because the second part already asked you to calculate the probability of the random variables that are in an interval with the lower limit mu x minus the standard deviation and upper limit is mu x plus the standard deviation. So if I only gave you the second part, basically you should know that you have to calculate both mu and the standard deviation in order to be able to calculate the probability for that interval. Is that clear? So, and for the mu, that's also, you know that you have to calculate the first and second moment. The first moment is actually the mu itself for the standard deviation. So, but now that we already calculated the mu and a standard deviation, we already know what is this interval. So this mu is that expected value of x, this value here, which was 2. The standard deviation we already calculated here, the square root of variance. So the probability is basically the probability of numbers between 1 and 3, including 1 and 3. In a discrete random variable, it's very important to note when it's included or not. In continuous random variable, it doesn't mean anything because it's 1 point over infinite point of an interval. Okay, so in continuous random variable, that equal sign here in continuous random variable would not affect your probability at all. Remember, the probability of each exact point is 0 in continuous. That's why we use the vicinity of any point as a probability. But in discontinuous discrete random variable, this equal sign changes everything. So pay attention to that. Now, what is the probability of x become between 1 and 3, including 1 and 3? Is probability of 1 plus probability of 2 plus probability of 3. Very simple. You have the PMF. You put the numbers in, you calculate the probability for each point, and you have the probability of your inner. Any question about this problem? Is that clear? Yes? Good. Now let's play with those numbers. In problem 9, we have a random variable x that has an expected value mu of x and the variance of sigma squared. Okay, the standard deviation squared. Now, we want to find the expected value and variance of our secondary random variable y, which is defined, the relation between y and x defined based on this function. Y is x minus mu of x over the standard deviation of x. Now, so basically this is the formula that relates y and x. We want expected value of y. So we said you could use the linear transformation property that the expected value would follow, okay, because mu and sigma are numbers, are constant number. They are not variable. X is variable, mu and sigma are constant numbers, okay, are absolute numbers. So you could calculate this, use that probability that says the expected value of ax plus b is the a times expected value of x plus b. Remember that? Now here, a is 1 over sigma x, the ratio of x, and b is minus mu x over sigma x. Is that clear? So now we use this formula and we calculate the expected value of y. if you note here that x minus mu x, if you divide that, if you put this value out of that using the formula, you have x expected value of x minus that mu x, which is the expected value of x. So if you do this formula, you would find that the expected value of y is going to be 0. Is that clear? Why is that? Now, without even like doing that, let's look at the value. This is how you have to like follow the process. But I want to give you one comment. When you see the y, the function that describes y based on x, you should instantly say, okay, the expected value is 0. Why? Because the denominator is the expected deviation on that function. Do you see that? The denominator on that function is x minus mu x, which is basically the distance of all the data from the mean. What is the mean value of those distance? Expected deviation. What is the value of expected deviation? Always 0. So the minute or the second you see the function, when you see that the denominator is the expected, is actually describing the expected deviation, you should instantly say, okay, the expected value of y is 0. Is that clear? Now, let's go for the variance. For the variance, we again could use the same linearity property that the variance. We said that if we have ax plus b, the variance of that linear transformation of x is a squared times of the variance of x. We already gone through that and actually saw the mathematical derivation in the course, in the class. So we directly use this formula, and we already know that the a is 1 over the standard deviation. So the variance of y is 1 over the standard deviation of x, the square times the variance. What is the standard deviation square? Variance itself. So the numerator and denominator cancel each other out. So the variance of y is 1. Is that clear? Are we good on that problem? Okay, how many problems we had? 10, 11, and 2. Okay, let's stop here and we go through the problem, the rest of the problem in the next session on Wednesday. And